Okay, Elaine.
All right.
Are we getting started?
Yeah.
Okay, cool. Welcome to April. Papers We Love, San Francisco.
Already April.
Yeah, it's already April. We get worse and worse at announcing this. Next time, we're going to announce them the day before. Is that?
No. Like for March, we announced like a month ahead of time.
Okay, this one
And then we
announced 2
dropped
weeks.
the ball in April again.
So we're trying to get better at this. We have some administrivia. Would you like to?
Also, like if you're ever antsy and you don't see anything on the meetup page, feel free to tweet at us and be like, hey, when is the next one? Because that'll actually help us debate and like get stuff posted.
You shouldn't have to, but we kind of suck at this year. We're tired this year.
We're tired. It's
okay.
Anyway.
Ooh, the Twitter handle. You know what? We don't have one in San Francisco.
No, I just do papers_we_love and then like add it. That's the handle, and then add in like SF at the end. So we have a Slack channel if you want to come and talk about papers. Again, don't know the URL off the top of my head, Inez.
Some sort of like Papers We Love that Slack, like something.
There's a Heroku in there. Like it's like paperswelove.heroku.slack.
I don't think we're putting our best foot forward.
No,
right now.
I'm sorry.
Come on, just like
but like we are very communicative and very friendly. So if you want to be in the Slack, like come talk to us and we'll add you.
Okay. The main thing that we wanted to say is that there's a form to sign up for talks. So if you want to speak, please help us out. Fill out the form, and then we will be on top of our shit.
Yes. Yeah. That form has also been tweeted out by both of us. Again, if you come to us or ping us, we'll also send it to you in particular. There was something else I wanted to talk about.
The next one is coming up. Yeah.
May
something. Thursday. Yes. But it's already like scheduled, so we have a date and we have it confirmed with the venue, so that's great. Thank you to GitHub for hosting us again. Woo! Yeah. There's Drew over there.
And Fastly for providing food.
Yes, and let's get started unless you have something else. There's Papers We Love Conf that is going to happen this year as well, and it's going to be, again, co-located with Strangeloop.
Yep.
And then that's all that we have in terms of administrivia.
Oh, and we're streaming this tonight. So live-streaming.github.com. Tweet it out to your friends. They can watch it in real time, etc.
And if not, we'll get the video sometime.
Yep.
All right. So normally the way this works is that we have 2 talks, a shorter one, and then a main length talk. And I get to introduce both speakers with their actual bio and something fake about them. So we're going to start with Omoju. She's a senior machine learning data scientist at GitHub. She has over a decade of experience in computational intelligence. In the past, she has co-led the nonprofit investment in computer science education for Google and served as a volunteer advisor to the Obama administration's White House Presidential Innovation Fellows. Omoju also carpools into the city with a Great Dane named Luna. Let's give it up for her.
All right. So today I'm presenting a paper from FATML, which is Fairness and Transparency in Machine Learning. It's like a new body of research. And this paper came out of the FATML conference a couple of months ago. So it's all the cool kids, how they fit in, popularity and demographic biases in recommendation, evaluation, and effectiveness. And it's coming out from Boise State University. This happens to be an area I'm very particularly excited about because, don't know if you guys know this, we rolled out a recommendation engine on GitHub. So if you log into GitHub and you look at your dashboard, we actually recommend repositories and projects for you based on people you follow, repositories that you've liked, and projects that you've watched. And our hope is that you get to participate, get inspired, and want to participate in some open source. So TLDR, the basics of this paper is pretty much who receives how much benefit from a system. So in a recommendation system, who receives the benefit from the system, and whoever that is, are we okay with it? So in the case of GitHub, for example, it would be amazing if we could bucket out the developer community into perhaps 3 buckets of beginner, intermediate, and novice, and then do recommendations along those 3 buckets to actually help people. So for example, if you're very new to programming, or if you're very new to development and you want to get better, it will be really helpful for us if you knew that you were actually at an intermediate level, so we can recommend things to you that helps you get along on your path even faster. So, recommender systems, what are they? I think pretty much everybody has probably interacted with some. if you've ever watched anything on Netflix, if you've used anything on Amazon, even the Apple Store, all of them are pretty much recommendation engines. YouTube, there's a lot of talk about this right now in the media because it seems as if our recommendation engines are putting us in unfriendly bubbles that make us sometimes not too happy. But so these are what recommendation engines are. And the research question is, are information systems good for all the people they affect? More importantly, do different demographic groups obtain different utility from the recommender systems? So once again, are information systems good for all the people that they affect? So the research in fairness in recommendation and search falls basically into these two major areas. Oh, something has gone off. Sorry, I'm sorry about that. My graphics have gone off somehow. But the first one is for whom? So basically, is the thing fair or is it not unfair? And I think this one especially is around things like when they're doing job recommendations and ads around job recommendations. If you fall into certain demographics, you may not get the recommendation of certain kind of jobs and things like that. And so that's number one. And even recently, Google, the developer group at Google put something out, I think it was last week ago, around embeddings and some of the challenges around what embeddings, that if you put, when I talk about what embeddings and what to vector, people know what I'm talking about. Okay, sorry about that. It's basically like a vectorized representation of a piece of knowledge, probably like a piece of text, and you put it in a hyperdimensional space, and it's supposed to preserve a bit of semantics so that things that are similar are in the same locations. And you can do interesting things like, you can say basically king plus X equals queen, and it gives you some kind of relationship that connects these two together, perhaps like marriage or something like that. And what they found that in those embedding spaces, there are lots of, if you train natural language processing systems in embedding spaces, funny things can happen. So if you say things like waitress, it's highly correlated with female. And if you say things like homekeeper, it's highly correlated with female. And maybe if you say things like president, it's highly correlated with male. And intrinsically, we want these things to be independent. So these are the kinds of questions like, is it fair, and for whom? Is it unfair? So on and so forth. And another one is, it can be unfair for the producers that produce it themselves. So they may not even have an idea that this is happening. So we're just building recommendation systems and we don't know what our recommendation systems are doing. So that's on our end. And if those things don't go too right, it can cause you to lose shareholder value and get lots of bad press. And worse, you can actually do major things on the world stage. On the other side, from the consumer, it actually can hurt you in different ways that can really be extremely deleterious. One of them that is more common is around policing. So if the recommendation systems that people use for policing have strong biases and certain areas get over-policed than others, and because of that, there's increase in police violence. Another one is around lending and doing recommendation systems and lending. If you fall into certain things that are negatively correlated, you get higher rates. And we want to figure out, make sure that we build our models to reduce the impact of those kinds of things. So, yep. And what we want to actually achieve is to get to statistical parity, that we have this independence, that we don't have this unfair negative correlations. So a quick things, the items are the things we recommend. The users are the people who receive or act on our recommendations. So for example, in a Netflix scenario, the item is the movies and shows that Netflix recommends to me. I am the user who receive and acts on the recommendation. So if I log into Netflix and it tells me like, I don't know, there's some show that's trending now, Ugly Desserts or something like that. And if I watch that show, I give them a signal that I'm interested in continuing to watch materials like that. So I receive and act on this. And then there's oftentimes there could be ratings. I don't know if they still do this, but I think a while back, some of these Netflix shows, at the end, they ask you to rate it. Is it still on? Does anybody even do that? I mean, nobody wants to get up. I don't want to get up, so I just watch the next one. So the ratings can also give us like information on whether our recommendations were good or bad. And we usually have evaluation strategies that fall into these three environments. The lab style user study is not really often done. because it's just quite more academic and it's harder to do. But often the ones that you see the most is the A/B testing. So you do online evaluation in real time and actually see what the users are doing. So if the user watches the show, you get the feedback that they watched the show, and that can reinforce the recommendation. If they don't, you get the feedback that they didn't watch the show, and then that can inform the recommendation. Another one is offline evaluation via prediction. So you take a piece of the data that you have. Maybe I have a data set, and I know what the real labels are. I know that, for example, users have really watched this show. Maybe I'm using like the example from this paper, they use Movie Lens, and they have the information that users have rated the movies that they watched. So they take some subset out and try to predict if the recommendation engine actually gives them the predictions of the ones, predicts the shows that the users have watched. So you can have offline evaluation, online evaluation, usually via A/B testing, and then you can have lab style user studies. The methodological background that this paper uses is a lot borrows heavily from Merolter in 2017. And what they did was, usually in recommendation engines, the evaluation works for the average effectiveness measures for all users. So when we build a recommendation engine, we don't bucket the users. We do an evaluation metrics on all the users in aggregate. And then you can pick strategies that produce better overall effectiveness for all the users in your data set. What they decided to do in their paper, and they did this with online search, I think in partnership with Microsoft and Bing, they segmented the users by demographic and then considered the effectiveness for individual groups. And then they considered strategies that provide benefits for some of the groups versus other parts of the groups. So they wanted to see if the search engine actually was giving the same utility if you're an older person or if you're a teenager, if you're male or you're female, because they wanted it to be very, very robust. And that's what they did. So the paper basically took that same approach and translated it in terms of search, they translated it to recommendation systems. They were not able to do an online evaluation strategy. Instead, they did an offline evaluation strategy. The data set they used the Movie Lens data set. Very interesting because the early Movie Lens data set actually has data on, it has demographic data. So there's data around age, there's data around gender. The next one they did was the Last FM data set. And so they had information. One of them had more information than the other on the demographics. That's why there's two of them. And so it was basically musical artists, the play count, and how people rated them. The gender one is a bit interesting because the gender that they use is it's binary. So you had to fall into either male or female. And this is the distribution of the demographics in the data set. As you can see from this data set, it's highly imbalanced around gender. There are more men in the data set than there are women. But the Last FM, the first one, is slightly closer to parity than the other ones. And then when it comes to age, you can really see that it's not very well distributed. It's highly skewed. In the Last FM one, the first one on top, that there are so many people that did not put their age there. So you have lots of unknowns. And in the Movie Lens one, the one in the middle, the Movie Lens ones are interesting because they skew heavily towards the demographic of people who will be graduate students. So people who are like 18 to 34. These are the people, because this came out of University of Minnesota, so those are the people who really use that recommendation engine the most. And so this is the protocol that they did. For the evaluation, they decided to use something called the NDGC, the Normalized Discounted Cumulative Gain, which is a metric that helps you understand the fraction of possible utility achieved. It's not perfect because it is highly correlated with the challenge of popularity. So if something is very popular, it pulls your metric very strongly. But it's problematic, but we still use it because overall it's good. So you get all the records you want, you get all your data sets, you split into training and testing. The training data gets put into the recommender spits out the recommendation, and then you take those recommendations and try to do prediction on them, and then you compare and you measure based on your test data. And so this is the experimental protocol that they did. They use several algorithms. They use algorithms that are recommendation algorithms, were very simple, non-personalized. So basically, recommend what is most popular, or recommend the data point that has the average rating that's closest to the average. Then they did personalized algorithms, which are basically collaborative filters. And based on that, the first two are the last FM, and the last one is the movie length. The red line that I drew on this shows that these are actually statistically significant. So looking at the first plot, the one to your left, the last FM 1K plot, you can see that the NDCG scores are very, very low. That's usually the norm. But you can see that it recommends, the recommendation favors females more than it does the male. And there's a statistically significant difference in the utility of the recommendation based on gender. So it actually recommends stronger, higher utility for female audiences. And it's interesting to note that in that data set, the female audiences are, I think they are not the majority, they are the minority subgroup. So it actually pulled in the direction of the minority subgroup. If you look at the movie lens one, there's a slight statistically significant difference in utility based on males. And that one is somewhat expected because a lot of that data skewed way heavily more than male. So the first important thing to notice is that the recommendation engines based on demographic have different utility. So whoever is using them has a different experience. So they are not without their biases. So that's the most important thing that this has actually helped us to confirm. The challenge is, how do we fix this? And number one, is this something you want? If this is a behavior that you want in your product, then fine. If this is not a behavior you want in your product, how do you mitigate against this? How do you actually fix it? So the same exact thing you can see for age. It's all not flat. So based on age, you get a different utility experience from the recommender engine. This one did not have very strong statistical significance. So like I said, differences exist. Different groups have different accuracy. Men in movie lens, women in the last FM, young and old in the last FM. And it's not a very simple, the biggest group has the most benefit story. That's not the case. The movie lens difference correlates with the number of users. The last FM differences anti-correlates. The biggest question now is what causes them? So some of the things that people are doing is like context matching to isolate the demographic influence. Like you want to eliminate some of the causal paths that may be important. So maybe, and this is a very hard one to do because there are so many things that can signal what is gender or what is ethnicity in your data set. It's not just literally taking that field out. It might just be a series of patterns that are highly correlated. So this is very hard. Another thing you can do is try to actually control for the obvious effects. So for example, something like profile size. So users with more data are easier to recommend for. So if your data set is highly skewed, so users with more data, the popular ones, are easier for you to recommend for because you have more data in that area. So maybe you want to balance your data set and remove the skew. And because of that, the commonalities in the larger group of users will often dominate. So even when you control for profile size, so here's an effect where they actually controlled for profile size and rebalance the data set so that it's gender balanced, there is still an effect. So controlling for profile size does not remove the effect. You can see the last FM, the female is green, it is still way higher. So that's not solving the problem, unfortunately. Then when you rebalance the data set, based on all the different algorithms, collaborative filtering and the non-personalized one, the one that gets you closest is the collaborative filtering user-to-user collaborative filtering algorithm. but it's not perfect too. It just gets you closest. You don't quite eliminate the effect, but you reduce the effect. So based on this, they found out that there was a slight overall accuracy decrease. And for many problems, for many industry applications, that might be something that might not be tolerable, or it might be. And then they reduced some of the discrepancies, but it did not reduce all the discrepancies. So correcting for the popularity bias. So the popularity bias, when you do that, the evaluation often prefers the popular recommendations. And then when they try to correct, the age discrepancies change. So one thing they did was, if you fix something, so when they tried to correct the gender ones, what they've ended up realizing that it corrected for the gender, but now it then skewed for age. For age. So it's almost like you're doing whack-a-mole. You fix one, it causes problems somewhere else. And this is 2018. This body of research is very, very nascent. We're just now at the point of saying, yes, there is an effect. We don't know what causes the effect. We don't know how we are going to control for the effects. And we are at the beginnings of doing research to figure that out. The challenge also is that this kind of research has a stronger role to play in industry than in academia, because often industry are the ones that can do online evaluation with A/B testing with large volumes of data. And they are often the ones that have large data sets that they can actually get demographic information. And the challenge is often industry shops don't want to spend that kind of time and effort doing this kind of R&D when they can just do other kinds of machine learning. But hopefully we will change that. So the limitations of this approach: offline data evaluation provides just a limited picture. Self-reported demographic data with hard gender binaries. And in the world that we live in today, hard gender binaries is not attainable. Gender is often about how someone presents within a context, and it can be fluid in a 24-hour window. So you need more robust models that can accommodate for that. The data set that they use is quite old. It's not new. And they just tried just a few algorithms. So this is what this paper basically did. We are very excited. I am personally excited about it, because at least we can have some kind of approaches to make sure that the models that we build moving forward are free and fair of bias. Do we take questions?
Hey, yeah, this is really interesting. I had a suggestion, or I don't know if there's any research done on this, about monitoring bias as a part of your, because as you said, right, like in an online system, you might be like unknowingly adding bias in the embeddings or something like that. So it's important for companies to have abilities or like some frameworks that can monitor gender biases like in real time, rather than have to, like, as a post-processing fact, come up with like, oh, there's a gender bias in this.
Yeah. So there needs to be actually instrumentation. And it's not just gender or ethnicity, because the gender one might even be slightly easier. The ethnicity one, or what is the protected class, is based on governments and nations. And if you're building a product that is of global scale, a person that is protected in the United States may not be protected in another place. So for example, as a Black woman in the United States, I am underrepresented, but when I go home to Nigeria, I am not. So you can't use the same approach for the same user. You have to basically do it based on where they are in that moment in time. So it's not trivial, and you have to build instrumentation that can allow for all of this to happen in real time.
I may have missed this. How do you correct for the predictability? Have some demographic that is vastly underrepresented in, say, American music. They might be much more predictable because you listen to one song in this genre, you listen to the only other 3 songs in this genre.
Yeah, that is very, very hard. It's always get more data. But if it's music and it's some obscure genre, there's just nothing you can do.
It seems like there's a lost opportunity here. The university students want access to online data, and the industry has it but doesn't have the time to do the research. So why aren't we partnering more with universities on this?
We could partner with the universities on this, somebody would have to be within a company, a Google, a GitHub, with a strong desire and time to say, I'm going to go down to Berkeley and I'm going to partner with these people and still write the code that I was paid to write. So you need to have will. And number two, beyond will, let's say you're even super excited and you're ready to do this. There's a big problem because this information we're talking about is private information. And how are we going to let the students have access to use this private information? You're violating GDPR in Europe, and it's just not ethically sound. So it's just quite tedious. Rules.
Does this research have anything to say about fairness for the items that are being recommended? So in a system for recommending GitHub repos, maybe your recommendation system is going to send a stampede of noobs to some project that is totally unprepared to receive them, or on YouTube, you might send trolls to some person's comments. And that would.
So the paper does not talk about that, but we at GitHub do that. We have a metric called, it's a fitness metric. And that fitness metric is assigned for each repo to make sure that there is, what's the word? When you want to give a message to somebody and the time it takes for them to reply back to you. There's a term for that thing. Engagement, like what is the engagement window? Because you might push people to this repository and the person is overwhelmed and they cannot do anything with this. So we actually put all that into the kinds of things we recommend. We want people to engage in open source, but we want to push them to open source projects that are open and ready to accept the people. So the paper says nothing about that, but reality is we do that because otherwise people are just going to be like, oh my God, so many issues. I don't know what to do. Thank you
So much.
Thank you.